Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled An Optimum Energy Efficient Approach for Sensor Clustering to Improve Network Lifetime in WSN. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. I am Deepak. Today I am here to present you one of the research that we have done in the domain of the IoT sensor networks, that how to communicate among the nodes or the sensors in the network and how to preserve their energy by introducing an optimization algorithm based strategy. So before moving to this video, let's talk about that what we will cover into this video. In this particular video, we will cover the different areas, like in which application area the developed system can be realistically usable, what are the application areas of it, then whatever the code is designed, how to execute it, what are the software requirements and the library requirements for it, which files have to be executed. Then we will cover that what are the current systems, those who are working in the same domain, what is the state of art, and what are the challenges found in them. Then overview to the proposed method, that what we have done and what is the objective behind it to propose that thing. Finally, an overview to the experimental outcomes and the results we will be given in this video. So let's start with the application areas. So you can see the application areas of the sensor network was initially in the wireless sensor networks only, but as the IoT came, there is no restriction and it is everywhere around us. So you can see IoT applications are specifically in the smart homes, healthcare systems, e-health, agriculture sector, which is one of the trending area of the sensor network communication. Then education sector, smart transportation, as you can see currently many vehicles are there, those are remotely surveillance, and every of the parameters like either heat or theft or accident, every is monitored by the sensors itself. So other than that, the marine industry, like smart ships, smart sea transportation, tracking of the things, all this comes under the sensor networks, because they are working by tracking the parameters using the sensors. But the problem with them is, like, these sensors are restricted with the battery constraints. So in order to handle that, these clustering protocols are in the existence, and daily basis of research is happening over the parameters. So inspired from this, we have developed this system, as you can see. Now further proceed with the code. So the folder that we will give you for the code will be like this. You just need to open it and you can have the all code files with you. The code is written in the MATLAB, so you must have the MATLAB software. It must be 2015 or above. The version that I am using here is R2019A, so you can use even 18, 17, 16, whatever you have, but make sure it should be a full version, not a trial version, because in that scenario you will not be able to run the codes of the MATLAB design, because the trial version is restricted with few of the libraries. So in order to run this code, you just need to copy this file, the path of the file, and then go to the MATLAB. Here you just need to paste the path, press enter. When you will press enter, all the files those were there in the folder will be shown here. So now in order to run the code, you have these two files. Rest of the files, this and this and this, these are the functions, those are called in these files. So the main file is this and this. So to run this code, you just need to select the file and click on the run button. When you will click on the run button, there are two scenarios. One is like when you will click on the arrow, you have certain options, but I suggest you just need to click on the green button and it will start running the code. So I'm going to start running. So as it is run, so you can see here two options are it is asking: sync at 100 by 100 and sync at 100 250. Let's say I'm taking the first option and press enter. OK, so it will start processing. So in the meantime it is running. Let's talk about what is the current systems and what are the problems identified in them. So we have take this base paper. So you can see this is the energy efficient protocol in the domain of the wireless sensor network. They have done the fuzzy based scheme for unequal multi-hopping. What they have done, they have applied the fuzzy logics for different stages. One for competition of that what will be the radius of the communication, then the cluster head selection has been done, then the nodes, those will be joined with those selected cluster head will be selected by it, and finally what will be the next cluster head to which the data is to be handed over, because they are doing the multi-hopping clustering. So they have developed 4 different fuzzy logic systems with them. Those are deciding the things in 4 different stages. But the problem that we have identified is that fuzzy is restricted with the things that whatever the rules you are mentioning, it is able to work with those only. If any of the scenario that comes out of these rules, then the bogus information will be there. The not a correct decision can be taken by the fuzzy. So in order to avoid that, we are proposing the our system. Secondly, this particular decisionable system is going to take time, because there are 4 different stages and the parameters for every stage need to be very precise. So we can't rely on a defined system, so it should be a dynamic and can be implemented in any of the scenarios. So inspired from this, we have proposed the method. In the proposed method, what we have done, let's talk about that. In the proposed method, we have implemented the scenario in which the initial clustering is being done by using the clustering algorithm. So k-mean clustering algorithm is being implemented. So you can see after defining the parameters and getting the information for the sync options, because the paper that we are following to that, if we need to compare, we need to follow the same configuration that they were using. So after choosing the case, all the information is being given here. You can see after choosing that, we are applying to calculate the initial cluster. This is basically calculating distance of each node with every node. Then we are calculating the total information of the nodes. Then this is basically distance from the sync, and then the main communication starts. In this, we are firstly checking that whether the nodes are dead or non-dead. So also saving their energy stats, because at end we need to show that dead nodes graph, energy node graph. Then k-mean is applied on all the parameters on or to get that which can be the centers for being a clusters. According to those centers, we are forming the clusters. Then we are applying the WA optimization algorithm in order to select the best cluster heads. In this optimization algorithm, it is proven to be the best in many of the scenarios in comparison to the traditional method like PSO, GA, GSA, and many others. So you can read about this algorithm. So it is basically WOA optimization, that whale optimization algorithm. So this is proven to be the best algorithm, because it was suggested recently and having certain advantages. So you can read about it from any of the paper. So this is whale optimization algorithm. So this algorithm is being implemented. Now the factors that we are considering for selection of the cluster heads are like node of energy, then d average, that is the average distance within the cluster of that node, distance of that node with the sync, and the delay as per of speed of light. So that these 4 parameters are chosen for selecting the best cluster head. Then when the best cluster head is being selected, the communication among the nodes has been done, where the nodes are initially checked that which node can be the cluster member, and then after getting the cluster members, we do have the cluster member selection has been done by using the equation of residual energy divided by distance from the cluster head. On that, it can be selected as a cluster member. Then the node with the highest cluster member chance is chosen as the cluster member. Then the communication is being done by choosing the energy model. You can see this, you can read it from everywhere, where distance of the communicating node is evaluated with the d naught, which is calculated by under the root of EFS upon EMP. Here you can see. So this is the basically energy model. So on that we have final parameters has been evaluated. Now let's talk about which cases we are considering. We have developed the whole code in different scenarios. One of the scenario when nodes are 100 and having subcategory that sink at the center and sink at the edge. Second scenario is when nodes are 1000, again when sink is at the center and sink at the edge. We have taken these cases from the base paper. So in the performance evaluation you can see the area they have considered is 200 by 200 and base station as a location of 100 100 and 100 250, and the nodes has been considered are scenario 100 and 1000. So we evaluated our system in the smaller area, not for the larger area. So that's why these four scenarios we have implemented. So these are the graphs that they have achieved for smaller scale network where 100 nodes are there and sync at the 100 100 nodes are there when sync is 100 250. Second file is, so this particular file is evaluated in code case 1 and 2. Then in code case 3 and 4 when nodes are increased to 1000, this is the second scenario. Here you can see 1000 nodes 100 100 base station location, 1000 nodes 100 250 of the base station location. So we have evaluated for small scale networks, not for the higher one, but it is expected that the same can be done for the higher one also and we can get the better result. So now let's see how the code is to be executed. So I'm clicking on this button. Now this time I'm choosing the case number 2 when sync is at 100 250 and nodes at 100. So when press enter 2, it will start executing. You can see the communication round has been started. It will take some time to execute the code. So two of the scenarios are here in case file this. Rest of the two codes with the 1000 nodes are in this file. So you can run any of the two codes to get the results. So I'm currently running the case with the 100 nodes and sync outside the network at 100 250. So it is running. As you can see, the current rounds have just reached to 888. So let's see the results that we have achieved. So these are the graph that we have achieved. So this is the network initially, where you can see the sync is placed outside the network at 100 250. This is for case 2. A proper labeling of the cases has been done. This is the dead node graph with respect to the communication rounds for the proposed method. So you can see our proposed method is staying undead for around 717 rounds, then it start depleting their energy and going down, right? Then it is moving to the, this is the graph of the remaining energy. So this is also as per the nodes getting dead in the network. Then we have shown that when the first node, when the last node and the half node is being dead in the network. So you can see first is like around 722, half at around 751, last at around 889. So then we have did the comparison with the base paper. So here you can see this is the curve that we have achieved from the base paper results for the case number 2 scenario, and our proposed method is staying for the longer period in comparison to the base paper's article. So finally the comparison of the remaining energy is also being shown into the graph, and the comparison of first node dead and half node dead is also shown. So you can see in all the three scenarios of first node, half node and dead, last node dead, it is better in comparison to the EEFUC. EEFUC is the base paper algorithm. So you can see we have taken these results, the base paper results, from the paper itself. You can see this blue curve, the last blue curve is of EEFUC. So we have marked these results directly in our system. You can see it is around 520 or 30. So similar, it is 520 or 30. Then our proposed curve is from the simulation. So we have compared the results and shows the better results in terms of the existing method. So further modifications are still possible. For those you can contact us directly. For the real-time implementation of these scenarios in the IoT based sensor networks, we can also assist you in that. So thanks for watching the video. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.